This is a demonstration of flow-based programming. It's a concept that was invented by Paul Morrison in the 1960s, and he's been promoting it and developing it ever since, most recently creating a program called DrawFBP, and this will generate a diagram and then go on to compile it and run it. So box A and box B represent processes. A is then communicating with B, sending information packets continually, A to B, A also to C, until its source is exhausted or until the system is closed down. Now the code is being maintained on GitHub. It's written in Java, and there are two components that we install. Maven has both of them. DrawFBP is the application. It's a version 2.20.8. Just click download and select jar from the list of options to download. Similarly for the library of components, JavaFBP, we're at version 4.1.3. And again, select downloads followed by jar, and you'll install that as well. Now there's a tutorial on GitHub, and the idea is to draw an end-to-end diagram. Now this is the simplest possible stage, and I'm going to cut to the chase and actually just construct this and generate it, compile it and run it. The tutorial suggests you take a longer path before actually getting the feedback, but I think we just need to show it working. So step 0, which I haven't shown you, is to confirm the installation. This is where that introduction to flow-based programming is. That was written by Paul, and software releases are on Maven. These two are the ones you want that I pointed out. The longer tutorial is here on GitHub, and the demonstration is using those two versions and Java 1.8 and a Windows 10 laptop. This is my email address. Now, step 1, begin. Pop up a block menu. Block related actions include choose component. We navigate down the library and we go to the IO input output package, read file. Now we get some description of what read file does, in particular what ports it needs to be connected, and if we need an initial information packet for the source. Now this is the path of the file that we're going to be reading. That's the file name, and it's living in my directory here. So I'm going to just cheat and cut and paste with that as well. And then I'll cheat again and copy that back to my buffer. OK to that. Now highlight the border, drag and drop on the highlighted border. Oh, we've got a different port name. That's because in is the default port name, which is the most common. The downstream port name is the port by the arrowhead, and that has to be called source. Now the in has disappeared because it isn't applicable in read file, because the data is coming from the file which is in the source. Out will be resolved in a second. What we've got to do now is to select the element type process for the diagram, and this will be show text with swing class. Swing is the Java user interface library, and we select that component. Again, navigate down. The components are all at the same level, packages in this case. Swing show text. Here's the description. Now we can resolve the left hand side, drag and drop. Now the output is connected and we can forget about that feedback. But what's missing on this side is another initial information packet, and that's going to be data from gardentools.csv. Again, use the highlight border drop, and the right click, very picky, right click exactly on the arrow. Right click, edit downstream port name, that's title. Maybe we should make the highlighted arrow a little bit wider. There's also an output port. That's if the network was going to be more complicated and we wanted to do something with the data after displaying it. We're not going to do that, so now we're just going to save this. I'm going to rename it so that I can use begin again. I'm going to rename it as done, OK to that. Overwrite the existing. Done. And now we can generate the Java network. In other words, convert the diagram into Java source code. You'll notice that the legends aren't being included. They're like comments in Java source code that don't make it into the class file. But what we have had added for us is the package name demo, because we're working in a subdirectory demo, and we always follow that structure, which is the Java convention, the source in demo subfolder of source, and the executable.class file in the demo subfolder of bin. So you can see here from just reading it that that's implemented what we drew. So now we're going to save that code. We must click select use suggested name, because that ensures it's the same name as the drawing. OK. Overwrite the existing Java and exit. So now we can compile it. Compile code, select that, go straight back to it. OK to that. It's compiling. Here's the feedback. It took step 01, done. It knew about the jar file, and it's generated the step 01 done class. So we can run it. Let me just highlight that file so we can see what it's going to be showing. Just to made up garden tool types, run code, step 01 done. OK. Now it's delivering one line at a time, so it's repeatedly delivering information packets. And that took us a couple of seconds to run, and we get some statistics about the contents that were displayed. That's it for now. Thank you very much for watching. I hope it was useful. Just note, when we close, there are sometimes messages in between where we opened the session and when we paused to make note of anything that we'd like you to report to us. In this case, everything was hunky-dory. So thank you once again, and I hope it was useful. Thank you for your time.